Swayam Prabha, free DTH channel for education.
Both x and y. Then we define the total differential of this one. So that I call as du. du is called as dou u by dou x into dx plus dou u by dou y into dy. Okay. So if I can find some, if u of x comma y is that, then this is called total differential of the total differential of u. Okay, that is called total differential of u. So that we call as du is equal to dou u by dou x into dx plus dou u by dou y into dy. Now, suppose u of x comma y equal to 0. Suppose this u of x comma y equal to 0, then what is going to be du? du is going to be 0. Similarly, if du equal to 0, sorry, u of x comma y equal to c, u of x comma y equal to c, then du is going to become 0. If du equal to 0, once again u of x comma y is going to become like some constant is going to come. Now the question is, okay, suppose the first order ODE, suppose some first order ODE is given, which is given in this form, m of xy into dx plus n of xy into dy equal to 0. Okay, some first order ODE is given in this form, m of xy into dx plus n of xy into dy, n of xy into dy, okay, n of xy into dy equal to 0 is given. This is given. Okay, now we call this equation as exact differentiable. Okay, we call this as exact differentiable. That means what? I can find a u. Suppose you can find a u such that, okay, you can find a u of x comma y such that, okay, such that what is the condition is that if you can find du, okay, you can find a u of x comma y such that this is going to be m of x comma y into dx plus n of xy into dy equal to, this is that, okay, u equal to m of xy comma dx plus n of xy dy is there. So if such u is existing, then we call this m of x comma y into dx plus n of x comma y into dy as exact. So in this case, what is the benefit? The benefit is that, so if du equal to 0, okay, so if you can find a u of x comma y such that this is going to be satisfied, then du equal to 0 implies that you can find u of x comma y equal to c. That means you can find the implicit answer for that. From that you can calculate the explicit solution for also. Okay. So now what I'm going to do, suppose this is such u is going to exist. Okay, suppose such u exists. Such u exists. Okay, that means this is exact ODE. Suppose this is exact ODE, then what I'm going to do, I'm going to compare this one with this one. Okay, so you can see that I'm going to compare m of xy into dx, okay, with this one, and n of x comma y with this one. So what I'm going to get, I'm going to get m of x comma y equal to dou u by dou x, and n of x comma y equal to dou u by dou y. Okay, so right hand side, left hand side du equal, okay, and the right hand side I have dou u by dou x, comparing the dx coefficient, so dou u by dou x equal to m of x comma y, dy I am comparing the respect by dou u by dou x. Okay, now what I have, suppose this should be exact. Okay, suppose this is need to be exact, then what is the condition I require? That I have to see. Okay, so suppose m and m comma n. So m is a variable of two variable functions. So m and n are, okay, m comma n are in C2 of a comma b. Okay, C2 of a comma b means I have the set of all sorry, not C2 of a comma b. Okay. Okay. Now we have a theorem. So the theorem is going to say like how some theorem which is going to say when the given function is going to be exact or not, that we are going to find it. Okay, so that's what we are going to do now. So what you have is that suppose you have function m comma n. Okay, m and n are given to you. Okay, m and n are in it's a function of two variables. So m and n comma n are belong to C1 of R, where R is some rectangle. Okay, R is nothing but some rectangle. A comma B cross C comma D. Okay, this is given. Okay, A comma B cross C comma D. So here R denotes the rectangle and C1 denotes the set of all functions, okay, of partial derivative whose partial derivatives are continuous in R. Okay, so that I call it as C1 of R. So now what I have suppose such a U. So instead of U, I'm just saying pi. So suppose some pi x is such that, okay, suppose some pi x is such that m equal to tau pi by dou x, okay, m equal to tau pi by dou x and n equal to tau pi by dou y, okay. Then we can say that, okay, what I can say is that, I can say that dou m by dou y, okay, by dou x, okay. So such pi is going to exist means I'm going to guarantee that when this pi is going to exist, because such u exists, then I can make this as the exact ODE and then I can solve the problem and then I can go to this step. Now we need to find when this is going to exist. Okay, when that is going to exist. So this such a pi or such a u is going to exist if and only if, okay, so dou m by dou y equal to dou m by dou y equal to dou m by dou x, or if dou m by dou y equal to dou m by dou x, then such a is going to exist, pi is going to exist. Okay, so that is going to be the result. We'll just prove that with some simple steps. Okay, this is very elementary proof, so we'll just give the proof of this theorem also. So what is the statement? So suppose you have a problem. Okay, for that problem, what I need to find is that I got to find pi and you got to do that. So there are two parts here. Since it is if and only if, there are two parts are there. So let us go one by one. So suppose it is given that, okay, suppose there exists pi such that, okay, dou pi by dou y, okay, dou pi by dou x, I think, dou pi by dou x. So suppose pi x is such that dou pi by dou x equal to m, okay, and dou pi by dou y equal to n is there. So suppose such pi x is such that this form, okay. Then what I have, I take dou means I have to take my, okay, my is nothing but dou by dou y, dou by dou y of dou pi by dou x, okay, which is nothing but dou square pi by dou y dou x, okay, which is nothing but dou square. I can write this as, since it is continuous partial derivative, I can just say that dou square by dou square by dou x dou y, I can write it, okay. This I can write it as dou by dou x of dou pi by dou y, okay. So what is dou pi by dou y? That is nothing but n, okay. So that is going to be nx, okay. So my equal to dou pi by dou y of m is going to be there, m is nothing but dou pi by dou x. I am substituting. So dou square pi by dou y by dou x, etc. is going to come. So we are going to come that. Okay. So this is the simple proof of that for one part. Now suppose we assume the converse. Suppose what we have the condition, okay, the converse part, this is if part we are having the converse part now, okay. Conversely, suppose in the converse part what I have, okay, converse part, I have my equal to nx system, okay, my equal to nx. Now what I need to find? I need to find a pi such that dou m pi by dou x equal to m and dou pi by dou y equal to m. So such a pi I got to find. So let us find that, okay. Suppose it is given my equal to nx is given. Now what I have, consider some function m equal to, okay, consider some function such that m equal to dou pi by dou pi of x comma y divided by dou x. Okay, suppose you found a function pi of x comma y such that m equal to dou pi of x comma y by dou x, where x is y is treated as a parent, okay, y we call it as a parent. Now choose pi such that what you need to do, you have to choose your pi such that pi of x comma y, okay, equal to, we are going to integrate this one. This is going to become like integral x naught to x. Okay, we are going to integrate with respect to x only. So that is going to become like integral x naught to x. Okay, m of x comma y into dx. Okay, I am going to integrate with respect to x. Therefore, I have something like h of y is going to come. Now, if you differentiate it, this is, you are going to get this one. Okay, if you differentiate this one with respect to x, you are going to get x naught to x, m of x comma y dx is going to come. So this is going to become like antiderivative. If you take it, that is going to become like m, and this is with respect to x only we are differentiating. With respect to y, it is constant. Therefore, with respect to x it is constant. Therefore, this differentiation is going to become 0. Therefore, you will get the same thing. Okay. So, if you take the partial derivative of x with respect, the Kirchhoff will vanish here. So, you don't need to worry about that. Now we have to use this condition my equal to nx, and then we have to find that. Okay. So, what I call is that now I am going to take what is my tau pi by tau y. Okay. Tau pi by tau y. Okay. Tau pi by tau y is nothing but n. So, tau pi by tau y equal to, I am going to take x naught to x. Okay. I am differentiating with respect to y. So, this is going to be tau m by tau y into dx plus I have to differentiate this one also. This is only one variable, okay, with respect to y only. Therefore, this is going to be Kirchhoff's law. So I can rewrite this equation as, okay, I can rewrite this as Kirchhoff's of y equal to tau pi by tau y. Okay, tau pi by tau y is nothing but we need tau pi by tau y equal to n. Okay, so I am going to write that Kirchhoff's of y equal to n minus, okay, integral x naught to x, okay, tau m by tau y. Okay, I am going to write this as I'm going to write this as my, okay, into dx. That's all. Okay. But now what is the n? Okay, integral x naught to x I have. What is n? This I can write as n minus Kirchhoff's of y, tau pi by tau y. Sorry. Okay. So I got to write this one. Kirchhoff's of y equal to, okay, tau pi by tau y minus integral x naught to x tau m by tau y into dx is going to come. But I need tau pi by tau y equal to n. Okay, I need tau pi by tau y equal to n should be found there. So that means I can write this as n minus integral n minus integral n minus integral my into dx is going to come. Okay, Kirchhoff's law. Okay, so now I am going to find this one. Okay, so my is already nothing but what is my? My is nx. Okay, so therefore I can write this as n minus integral. So this is x naught to x. Here also x naught to x. Okay, here it is going to be n x. Okay, my equal to nx. I am going to use this one. My equal to nx. Therefore this is going to be my minus nx into dx is going to be there. Okay, nx dx is there. Now what I am going to do? I am going to find this one. So this is with respect to x I am integrating. Therefore this is going to become like, I am going to get this answer as Kirchhoff's of y is going to become like, okay, Kirchhoff's of y is going to become like n minus, if I integrate, this is x naught to x is there. So I am going to have n of x comma y, okay, minus n of x comma y plus n of x naught comma y naught is going to come. X naught comma y is going to come. Okay. So this one, what I am going to have? So n gets cancelled. Okay, if n gets cancelled, you are going to get only n of x naught comma y is going to come. Okay, this is also n of x comma y, so both are getting cancelled. So Kirchhoff's of y is this one. Therefore, Kirchhoff of y you can find it as integral. Here you got to integrate with respect to second variable. Okay, we are integrating with respect to y. Therefore, this is going to become like y naught to y. Okay, y naught to y n of x naught comma n of x naught comma y into dy is going to come. Therefore, I found my Kirchhoff of y. So what you are going to get is that once you found the Kirchhoff of y, what you are going to do is that you can find your pi of x comma y. So pi of x comma y is going to become like integral x naught to x m of x comma y into dx plus integral n y naught to y n of x comma y into dy is going to come. This is nothing but your pi, which is going to satisfy that requirement, and hence the proof follows. Okay. Okay. So let us see some example. So whether the following equation is exact or not, that we need to prove. Okay. Let us see that. So remember that we are solving all these things in order to solve this problem. Okay. So for that purpose only we are solving. We are going to obtain that in very soon. How to obtain that answer for that, and then we will see that. Okay. So let us see how to obtain that. Okay. Now what I have prove or disprove this one. So 3y square e power 3y cube e power 3xy. Okay. 3y cube. So we got to see whether it is exact or not. So 3y cube e power 3xy minus 1, okay, plus integral 2y e power 3xy plus 3xy square e power 3xy into dy by dx. Dy by dx is also dy by dx equal to 0. So you need to check whether it is exact or not. So for exact or not, what you need to check? For exact, you have to check my equal to nx. You have to check. If you check that, then that is fine. Okay. So what is m here? M is nothing but m is nothing but here 2y into e power 3xy plus 3xy square e power 3xy is going to come. Okay. Now we need to find what is our nx and my. So we need to say that it is exact. Okay, it is exact if my equal to nx is there. Okay, if my equal to nx, then we see that it is exact. So we need to find whether my equal to nx is going to come. So let us find what is my. My is going to be 3y into y cube. So that is going to become like 9y square e power 3xy plus, okay, chain rule. So I'm just keeping this one constant and integrating. Now keeping this one constant and integrating. So therefore you are going to get 3y cube into e power 3xy into, with respect to y you are differentiating. Therefore we are going to get another 3x is going to come. So that is going to become like 9y square e power 3xy plus 9y cube 9xy cube. Okay, 9xy cube e power 3xy is going to come. Okay. Now let us find for n. Okay, for n we have to find. So for n, okay. So I differentiated this one. Now I got to differentiate the second one. So in that case, I'm going to differentiate this one. This is going to become like 3y square e power 3xy. Okay, because I'm differentiating with respect to x, so 3y square e power 3xy plus I got to differentiate, keeping this constant, differentiating this one. I'm going to have 3xy square into e power 3xy into 3y is going to come. Okay, so therefore I can write as 2y into 3y, so 6y square, another 3y square, so 9y square e power 3xy plus 3xy 3y, so 9xy cube into e power 3xy is going to come. So you can see that my equal to nx. Okay, my is going to be nx. Therefore you can say that this is going to be exact. So you can say that this you can say that the answer is means the, you can find a pi such that this is going to be upright. Okay, so using the theorem you can do that, how to find the exactness. Okay, that we can do that. So okay, so there is a exercise for you. So either you prove it or disprove. The following equation is exact. Okay, for example, you can take cos x plus y into dx plus 3y square plus 2y into cos x plus y dy equal to 0. So all these 5 problems, I just give it as an exercise. What you can do is that you can just check whether it is going to be exact ODE or not. Okay, so I just leave it as an exercise for you. Next one. Suppose, okay, suppose you found a problem for which it is not exact. Okay, you don't have an exactness over here. So in that case, what I'm going to do, I can check whether such something, if I multiply by something, then will I get some exactness or not. So that we are going to see. Suppose I have m of x comma y into dx plus n of x comma y into dy, okay, equal to 0 is there. Suppose this is not exact. That means what? I don't have my equal to nx is not there. If my equal to nx, that becomes exact. Suppose this condition is not there. If it is not satisfying that, then how do I find that? Suppose I can multiply by something in order to make it exact. Is it possible or not? So that is what we are going to do. Suppose mxy plus dx plus nxy dy is not exact, okay, and if there exists a function nu, okay, nu of x comma y is existing, such that what you are going to do, nu into m of x comma y into dx plus nu into n of x comma y into dy is exact. Means what I mean, I can find some pi such that t pi is going to be this one. Then I can find once again this is going to become like 0. I can write pi of x comma y equal to 0 and pi of x comma y t pi equal to 0. Therefore I can find pi of x comma y equal to c. I can find. Okay, so that is the meaning of this one. So if I make this new multiplying by new, If I get this as exact, then this nu is called as integrating factor. This nu is called as integrating factor. Okay. Now this concept is going to be useful to find our integrating factor for our problem which we are dealing with. Okay. So by so if such things are existing, then by these theorems, this is not exact, but this is exact. If it is exact, what does it mean? I have dou nu of m by dou y, okay, dou nu of m by dou y equal to dou nu of n, dou nu n by dou x. Okay, this is going to be there. But what does it mean? I have this is going to be nu y into m plus nu into my equal to nu into n, nu x into n plus nu into nx is going to be there. Okay, this is going to be there. Okay, so I can't deal that again, complex cases again. I am going to assume some of the things. Suppose, okay, condition 1, I am going to assume that, okay, we cannot solve all the problems, so I am going to solve only some assumptions. Suppose nu is a function of x only. Nu is a function of x only. So in that case, what is going to be nu y? Nu y is going to become 0. If nu y becomes 0, this is going to become 0. Okay, so that means this term is going to vanish. So I am going to have nu into my equal to nu x into n minus plus nu into nx is going to come. Okay, so in that case, I can just club the new terms together. So nu is going to become like nu into my minus nx. I'm just bringing it over here equal to nu x into n is going to come. So that means I have nu x by nu equal to 1 by n into, okay, my minus nx is going to come. So means I am going to do the separation of variable. So nu is there and this is there, so I am going to get it. Okay. So in that case, what I can do, I can integrate this one. So this is going to become like ln nu, okay, ln nu equal to ln of. So I can integrate this one. So integral 1 by n into my minus nx is going to come into dx is going to come. So therefore nu is going to become like e power minus e power plus only not minus e power integral 1 by n into my minus nx into dx is going to come. Okay. So if you have that, okay, if it is xr and if nu is a function of x alone, if nu is a function of x alone, then you have that your new integrating factor is going to be 1 by n into my minus nx dx is going to come. Now let us go another way. Okay, so instead of this one, suppose, okay, so I just change this one. I have again the same thing. Nu y into m is there. Okay, I'm going to erase this. Suppose instead of this one, I have nu is a function of y alone. Nu is a function of nu y alone. In that case, nu x is becoming 0. Okay, so in that case, what it is going to come? This is going to 0. Okay, this is going to become 0. So in that case, once again, I am having nu y into m plus nu into my equal to nu into nx is going to come. So again, I can write this as nu y into m equal to nu of nx minus my. I can do it. So that means I can write this as nu y by nu equal to 1 by n into 1 by m into, okay, nx minus my. I can do it. Therefore, in this case, nu is going to become like in e power integral nx minus my of dy divided by dx. See, in the previous one, it was divided by m. In the previous case, it was with respect to x, so my minus nx dx was there. Here with respect to y, therefore this is with respect to dy and divided by m is going to come. Okay, so this is the another one for integrating factor if u is as simple as nu. So let us see some problem for this one. How to find the integrating factor for this problem? Okay, xy dx plus 2x squared 3y squared minus 20. So let us see that. Okay, let us solve some problem and then find what is the integrating factor. Okay, and we will see like how it could help us to solve the original problem. Okay, so what I have is that I have that xy into dx is there. Okay, so my problem is xy into dx plus 2x square plus 3y square minus 20 into dy is there. Okay, minus 20 into dy equal to 0 is there. So first we got to check whether it is exact or not. So what is my m? M is going to be xy and n is going to be 2x square plus 3y square minus 20. Okay. So what is mx? We need to find my. So what is my? My is nothing but x. What is nx? Nx is nothing but 4x. Okay. Therefore my not equal to nx. Okay. So now we have to deal two cases. Suppose I have nu equal to nu x. Okay, nu is as simple as nu x. We got to find the integrating factor. Suppose nu is equal to nu x, then what I need to do is that I have to find what is my value for the integral. So if nu equal to nu x, we have the formula that nu is can be written as nu equal to nu of x. I have that nu is equal to e power integral 1 by n into my minus nx into dx system. When nu is equal to nu y, I have nu is equal to e power integral 1 by m into 1 by m into nx minus my into dy is there. Okay, so first is with respect to x and this is. So anyhow, I have to find my and nx is there. Okay, my minus nx is there and nx minus my is there. So I need to find what all the things should be done. So my minus nx I got to find. So my already found and nx also I got. Now what you need to do? You got to find nu x. You got to find. Okay. So nu you got to find. So nu equal to nu of x. Then what is nu? You got to find. So nu is going to be e power integral 1 by n into my minus nx into dx. So that is nothing but e power integral 1 by n. 1 by n is nothing but 1 by n is nothing but 1 by 2x square plus 3y square minus 20. Okay, into my is nothing but x. Okay, and my minus x, so x minus 4x into dx is going to come. So this is going to be e power integral minus 3x divided by 2x square plus 3y square minus 20 is there. Okay, into dx. But you see this one, we assume that nu is equal to nu of x. But if you integrate this one, there is a y involved here. So if you are assuming nu equal to nu of x, then in the after the integration, there should not be y should not be involved over there. But clearly it says that there is a y involved over there. Therefore, we cannot proceed further. Okay, not proceed. Okay, do not proceed because you cannot find them. So therefore, what I have to do, I have to deal with that differently. Now I am going to take nu is equal to nu of second case. Okay, so in that case, what I am going to have, nu is going to become like in the e power integral 1 by m into nx minus my into dy is going to come. So in this case, e power 1 by m is nothing but xy, 1 by xy into nx minus my. So nx minus my is going to be 4x minus x into dy. Okay, so this is going to become like e power integral 3x by xy into dy. So xx get cancelled. So you are going to get e power integral 3y dy is going to come. So here you can see that mu is a function of y only. There is no x involved here. So therefore here we can proceed. So this is going to become like e power ln y cube. Okay. Therefore you can see that which implies y cube. Okay. Therefore your nu is going to become like y cube. So you can say that nu is nothing but y cube. Your nu is y cube. So that you can just use it for finding the solution for this problem. So if you substitute it over here, so you can just verify that. So if I put m equal to, okay, in the new problem, okay, let's say m1 equal to x into y power 4, because you got to multiply by y cube, so x power y power 4. Similarly, n1 is equal to, you can put it like 2x square y cube plus 3y power 5 minus 20. Okay, now you find what is your my, that is going to become like 4x y cube, okay, and nx is going to become like, again, this is going to become like 4xy cube is going to come. Okay, so both are simple. Okay, you can verify that. Okay. Now let us start here and then we'll find how to solve this problem. dy by dx plus p of x into y equal to r of x. How do we solve this problem? Okay. So in this case, you can clearly verify that. So we'll see this problem. Okay. Now we are going to deal this problem. So what is it going to happen here? So let us consider our original problem which we are supposed to solve. Okay. So in this case, what we are going to have. Let us solve this original problem. So dy by dx plus p of x into y equal to r of x is there. So in this, we solve the problem dy by dx plus p of x into y equal to r of x we are going to solve. Okay. Now I am going to consider. Okay. So for this problem, what I am going to consider this is the one which we need to see. So if I write that in the exact form, then we are going to obtain the solution. Suppose if I rewrite this equation, what I am going to get p of x into y minus r of x. Okay, into dx plus dy equal to 0 is going to come. So I can rewrite, I can find my y, m is nothing but p of x into y minus r of x, and n is nothing but 1. So if it is exact, what I have my is equal to nx would be there, but what is my is nothing but p of x, and nx is 0. Okay, so if it is p of x equal to 0 only, I will have this exact. If p of x is not equal to, okay, p of x equal to 0 means already you have till term. P of x equal to 0 case is already case 1 that we don't need to worry about. So we are going to till p of x not equal to 0. So in this case, what I am going to do is that I am going to find the exactness. So we don't have the integrate, we are going to multiply by an integrating factor. Suppose you found a nu, okay, found a function nu such that, okay, that is satisfying this one. D nu of y, okay, d nu of y is going to satisfy this one. Okay, dd of y is going to satisfy this one. We are going to get nu into y dash, okay, plus p of x into nu into p of x into y is going to be there. That means what I am going to do is that, so this is the equation I have. What I am going to do is that I am going to multiply. Okay, I am going to multiply. So for this one, what I am going to do is that I am going to multiply by nu. So if I multiply, what I am going to get nu into y dash plus nu into p of x into y equal to nu into r of x is going to come. Now I have to find my nu in such a way that how I am going to find? I am going to find in such a way that this is going to be t nu y of y is going to come. Okay, such that this is going to become like nu into r of x is going to come, and I can just do the same job whatever we have, and then we can find the solution for this one. That's what we are going to do. So that means what I have. Suppose my d nu of y is satisfying this one. Okay, dv of y is satisfying only the left hand side, this is satisfying this one. That is going to be exact. So in that case, what I can do, so I have to evaluate this one. So dv of y, what is dv of y? dv of y is nothing but nu into y dash plus nu dash into y, which is equal to nu into y dash plus nu into p of x into y is going to be there. Now you can see that this is nu y dash, this is nu y dash. So you can cancel these two terms together. You can cancel these two terms, and then you have nu dash into y equal to nu into p of x into y is going to be there. Okay. Again here you can see that y gets cancelled. Okay. So you are going to get only nu dash equal to p of nu into p of x is going to come. Okay. So therefore you can write it as nu dash by nu equal to p of x. You can write it. So this is once again you can do the same job what we did over here. So nu is going to become like e power p dx is going to come. Nu is going to be e power p dx. Okay, p of x into dx is going to come. So that is nothing but your nu is going to come. Okay. So if you found that one, then what you can do is that nu is already found. So you can just solve this problem once again. Okay, nu is found to you. So nu is already given to you. So you got d nu of y equal to nu of r of x is there. Now I can integrate this one. So this one I can integrate. So what you are going to get, if I integrate on both sides, you are going to get nu of y equal to integral nu of r of x into dx is going to come. Plus some constant will come. Okay, some constant is going to come. Therefore your y is going to become like, y is going to be 1 by mu into integral nu into r of x dx plus c is going to come. But what is mu? Mu is e power p dx. Therefore, this is going to become like y is going to become like e power minus p dx integral e power p dx into r of x dx plus c is going to come. Okay, this is nothing but your y. Okay. Now, if we have something like initial conditions are there, some initial conditions are given, then in that case what you can do is that you can just substitute over here and you can evaluate that. Therefore, you are going to get some constant over there. So that I call to call it as the c is going to give some constant. So I can just write this as e power minus p dx integral e power p dx r of x dx plus some y dot star is going to. Okay. So that means what it is going to say, your output response, the total output is the total output response is there. So this is going to be everywhere. Okay, bracket is there. Remember that. Don't forget the bracket over here because this new is part both. Because here it should be ordered the constant, therefore it should come over here. Okay, so it should be with this one. Okay, so now what we have, so y is nothing but the total output. The total output is the sum of two things. One is nothing but the response to input, okay, response to the input R, and another is the initial data. So this is nothing but the initial data. Depending on that, you have this is nothing but the input you have to the input R, okay, and the initial data is going to be. So that is going to be the total solution is going to be, the general solution is going to be of this one. So therefore, we have found this one. So y equal to e power minus p dx into e power p dx is going to be there. Now let us verify whether we get the same thing over here. Suppose I have suppose my p of x is 0. Okay, in the first case, suppose p of x is 0, this is going to be 1, this is going to be 1. You are going to get only r of x into dx. In that case, plus y naught star is there, that is there already. Okay, y naught star is there. So in this case, y naught will become the y naught. So you are going to get. Now suppose r of x equal to 0. If r of x is equal to 0, first integral is going to vanish. You are going to get y naught star into e power minus p dx, almost same thing is going to come. Okay, so that is the conditions for that. So let us solve some problem. Okay, so dy by dx plus y equal to x, y of 0 equal to 4 is given. Now let us solve how to obtain the solution for this one using this method. So what I have only this formula. So I can erase everything. Okay, I can erase these three cases. Okay, let this exact thing can be there. So let us erase everything. Only this case. Okay, this is going to deal everything. Whether case 1 or case 2 or case 3, it is going to deal everything. So y is going to become like e power minus p dx of integral e power p dx into r of x into dx plus some y naught star is going to come. Okay. Let's see why this y naught star is there. I'm not keeping y naught. Okay, let's see that because it is not going to be the same. Y naught is going to come. Let us see that. So what I have the problem dy by dx plus y equal to x. Okay, and y of 0 equal to 4. Okay, so what is p of x here? P of x is 1 here, r of x is x here. So I can substitute over here. So y is going to become like e power minus integral p dx. Okay, p is 1, so into dx integral e power p dx, x is 1, p of x is 1, so dx, okay, into r of x, which is nothing but x, plus some constant I am going to put. Okay, so this is not 4, it is not going to become 4. You can see that. Okay, it is not going to become 4. You are going to get some different constant over here. Okay, so let us see this one. So in this case, what I am going to get? I am going to get y of y equal to e power p dx. So therefore, it is going to be minus x, and this is going to become like e power x into x. Dx is there. Dx plus x into d of ex. Okay, x into d of ex plus c. Okay, so this is going to become like e power minus x into udv. Therefore, x into e power x minus vdu. Therefore, e power x into dx plus c is going to come. So this I can write as e power minus x into e power x minus e power x. Okay, plus c is going to come. So I can write it as x minus 1 plus c into e power minus x is going to come. Okay, so y is this one. Now y of 0 equal to 4. Therefore, 4 equal to minus 1 plus c, which implies c equal to 5. Okay, therefore your y is going to become like e power minus x into integral. Sorry, not integral. Already we have done that. So e power minus x also we have done. So y is going to be x minus 1 plus 5 into e power minus x. This is going to be your solution. Okay. Suppose r of x is 0 here, then what we are going to see? Okay, if r of x is 0. Okay, if r of x is 0 here, you can see that. See here, y naught star I have kept. Whereas in the whereas if I see the if you just see the r of x equal to 0 term, it is completely y naught will come. Okay, it will not come. Y naught star will not change. Okay, so let us see this one. Suppose x equal. Suppose we are solving this problem. dy by dx plus y equal to 0 is there. Okay, so in that case, what it is going to come? Again, the same thing. Y equal to e power minus p dx, so that is going to become like e power minus x. Okay, integral e power x, this is going to become 0. You are going to come only c is going to come. Okay, only c is going to come. So c into e power minus x is there, y is there. Now if we substitute y of 0 equal to 4, in that case 4 equal to c into e power minus x is going to come. So in that case y equal to 4 into e power minus x is there. Okay, so e power minus x, so this is 0. So c equal to 0, c equal to 4. So 4 into e power minus x is going to come. So keep remember that it is not y naught, it is y naught star. It is going to change. Okay, it is not going to be y naught, it is going to be y naught star. So that you should be very careful with that. Okay, next one. So you can see the solution of this problem also. Okay, x minus 1 plus 5 into e power minus x, which is going to be a decaying curve, which you can see.